Good morning, students. I hope you've had a wonderful weekend. This morning I would like to complete a practice problem with you. So I have uploaded this file to Canvas. It's called Impulse-Momentum Theorem, the truck. So I'm going to read the problem. I'm going to underline the important information. We are going to generate a column of knowns and draw a picture. So a truck with a mass of 1,960 kilograms is traveling at a velocity of 20 meters per second and comes to a stop in 7 seconds. So in part A, it wants us to calculate the braking force. In part B, it wants us to calculate the acceleration of the truck using Newton's second law of motion. And in part C, it wants to know the displacement while the truck is braking. So let's go ahead and generate a column of knowns. We underlined some important information here. So the mass of the truck, 1,960 kilograms. The initial velocity is 20 meters per second. It comes to a stop, so the final velocity is 0 meters per second, and our time interval is 7 seconds. So if we draw a simple picture, here we have, this is our truck. We have our initial velocity at 20 meters per second. And we're going to come to a stop. So our final velocity is 0 meters per second. And let's go ahead and draw a coordinate system. So we know velocity is a vector and displacement is a vector. Also force and acceleration are vectors as well. So let's say we have a positive x direction here, negative x direction. We're going to have a final displacement during braking. So I'll just use a subscript of b to represent braking. And we have a time interval identified by delta t as 7 seconds. Now, this problem, to calculate the braking force, we're going to be required to use the Impulse-Momentum Theorem. So this tells us that the impulse applied to the object is going to equal a change in momentum for the object. And so we have delta p. Remember, the Greek letter delta represents change in, and lowercase p represents momentum. So we have our applied force multiplied by the time interval is equal to the final momentum of the object minus the initial momentum of the object. Now what I want to do here is just focus on the right side of the equal sign. So what we have, the final momentum, is the mass of our truck multiplied by its final velocity minus the mass of the truck multiplied by its initial velocity. Now you already know that the truck comes to a stop. So the final velocity is 0. 0 times our mass. This will go to 0, so we really don't need to worry about it anymore. Let's go ahead and fill in some values here. I have my force, and I'm going to be more specific than just F. I want to use a subscript of braking. Our time interval is 7 seconds minus the mass of our object, 1,960 kilograms, and our initial velocity is 20 meters per second. Now what we're going to do to isolate the force of braking is divide both sides of the equal sign by 7 seconds. So on the left side of the equal sign, 7 seconds will cancel out right there. So let's go ahead and get out your calculator. I have a negative 1960 times 20. We're going to divide this by 7. So my braking force is negative 5,600 newtons. And we know that it's going to be negative because our braking force is applied in the opposite direction of our initial velocity. So our initial velocity is positive x direction, so we have a positive 20 meters per second. But the braking force is applied in a negative x direction, so that's going to slow us down. Our net force is in the negative x direction. Now part B wants us to calculate the acceleration of the object using Newton's second law of motion. So we know that Newton's second law, the acceleration of an object is directly proportional to the net force applied to the object and inversely proportional to the object's mass. So what we have here, our net force is negative 5,600. And it's newtons, but we know that 1 newton is equal to 1 kilogram meter per second squared. So what let's do is let's just go ahead and break the newton down and use the kilogram meter per second squared. We're going to divide by the mass of the truck, which is 1,960 kilograms. So let's talk about the numerical value first. I have negative 5,600 divided by 1,960. This is going to give me negative 2.857. Now let's take a look at our units here. In my numerator, I have kilogram meters per second squared, and in my denominator, kilograms. And algebraically, we can write this as kilograms over 1. So when we divide fractions, it's like multiplying by the inverse of the denominator. So I have kilogram meters per second squared times the inverse of our denominator, which is going to be 1 over kilogram. The kilograms will cancel, leaving us with units of meters per second squared. Okay, so our answer is negative 2.857 meters per second squared. Okay? All right. Now, part C, I would like you to do this on your own, but I want to get you started. So there are some options to calculate the braking distance, or the displacement, sorry. Okay, so we can use, we have several different options. We can say, I'll call this equation 1, okay? Okay, we have an option here, number 2. Okay, this is option number 2. And option number 3, we have right there. Now, these are our 3 options to calculate the displacement while the truck is braking. Okay, so when it's traveling at 20 meters per second, it begins to brake until it stops, okay? One of these equations we absolutely cannot use, okay? So when you turn your assignment in, give me a sentence or two about which equation we cannot use and tell me why, okay? So I need you to take a picture of your assignment, send me an email, and I will give you credit. And you know what? I will give you some extra points if you tell me which one of these equations that we cannot use in this situation. I hope you have a great day.